Hello, students. We've got a few questions coming at you from 12.1. Let's take a look and see what we can do here. So I've got question 19, which is down here. Let me zoom in a little bit. That's a little far away if you're watching on the video screen. Here we go. Describe how to construct the center of a circle if the center is not marked. How can I construct this center? Okay, so we got to remember the center is a point that is equidistant from every other point inside the circle. Okay, so let's go back to what we do know how to do. Right, what did we learn in class? We saw in class that we could, if we were given 3 points, we could find a point that was the same distance from all of them. So you might remember what we did. Let me go back to straight line shape. So we found the a perpendicular bisector of one side, found a perpendicular bisector of another side, and where those intersected was the point that would go through all 3 of them as a circle. Now I'm just ballparking that here, so I guess I might be off a little bit. Shall we see? I wonder how close I can get. Did I get close? And I just grabbed a radius too, so it might not be this radius. I'm gonna have to shrink it down. What? That is awesome. Okay. That's a fluke. Don't worry, that's a total fluke. I'm not that good at geometry. So that's how we could do it. So if I know 3 points, I can find the center of a circle. So I guess my hint for this one is if you have a circle, right? If I have a circle and the center is not marked, how can I find the center? And I guess my hint is forget about a circle. What would you do if you just had 3 points? How would you find the center? And so then think, could you maybe put some points on a circle, just some points, and see what you could do from there. All right, there we go. Now, when they're saying, just so we're on the same page as well, when they say construct, they're talking about compass and straight edge. They are not talking about patty paper. Okay. Now, if you had patty paper, oh, absolutely. In a sense, you could kind of fold like this part of the circle, fold that over onto this other part of the circle, just line them up and then make a crease and then repeat that process, right? Except now, let me change color. So now I'd find another part of the circle here, and I'd fold that over onto a part of the circle here, and then I would make a crease. And where those creases met, if you were doing patty paper, would be the center of your circle. Okay, so when they say how to construct, they are not talking about patty paper. And I'll be very clear as well. If I say construct, I mean compass and straight edge. This is what we mean when we say construct. Okay, if I want you to use anything else, I will be very clear. I will say build this or construct this using patty paper. Build this or construct this using only a ruler, something like that, okay? But your default is if it says construct, we're going to use a compass and a straight edge. So there's my hint for number 19. Let's see here. I'm going to MC 18. Okay, let's take a look. Next page, MC 18, right here. The teacher challenges her students to prove theorem 12.4 using side, side, side. She sketches ABC. Okay, so let's mark this. We got to be careful. So we got to, this is, I'm telling you, when you're doing your homework, seriously, sketches this with AC equal to BC. Okay, so AC, mark it, equal to BC. Got it. Then provides the first step in the proof by connecting C with the midpoint of AB. It's the midpoint. So if it's the midpoint, then those 2 sides have to be the same. How would you complete the proof? Now remember, they want you to use side, side, side. Okay. Now you might be tempted to say something along the lines of, aha, it goes straight down, so this is perpendicular. You can't say something comes straight down, so it's perpendicular unless you know it's perpendicular. All you know is that you connected it to the midpoint. So the only thing I can do is label the midpoint. It may turn out that they are perpendicular, but we cannot guarantee it. Okay. Can't guarantee it by just drawing the line segment. So make sure that you take a look at that. And again, the huge hint is up here. If you're fighting with this and you're trying to figure out angles, the teacher is asking you to prove a theorem using side, 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 not any other technique. Okay. In this situation, in this case, you couldn't use any other technique anyway. You couldn't say this angle is equal to that. And the reason is then you can't guarantee you would have had the midpoint. So you could either say, build the angle bisector of angle C, in which case I lose out on these pieces down here, or I can say connect straight across to the midpoint, which is what we have in our situation. So that's what I would recommend. And there you go. So with the information they've given you, you have two sides that are congruent. Your job is to find, see if the third side is, if you have a reason for why. Next up, 22. Okay, ABC is congruent to BAC is generally false. Okay, well, let's take a look. Is it generally, oh, wrong one. I did like a light mist, not an actual, write it over. Let's see. All right, here we go. Okay, so I have a triangle. Let's make sure it's like scalene just so we don't run into any issues. If it's isosceles, we might end up being correct accidentally. So here's A, here's B, here's C. Okay, and so now what I'm going to do is I'm going to draw another one of those right below it. Okay, and I'm going to draw this one as A, B, C. That's a horrible triangle, but it's there. Okay, and that's because I want to match them up. And it's really hard to match up when you're looking at just one shape. So that's my recommendation. Match up, you just draw it twice. Okay, ABC is congruent to BAC. Let's see here. So that means go one at a time. AB has to match up with BA. Let's check. Those do match up because BA and AB are the same. Okay, so I'd say AB is congruent to BA. Okay, you can say reflexive. You could say same shape. Excuse me. All right, there we go. Next up, BC has to be the same as AC. Let's see here. BC. Okay, BC is right here. Oops, let me change color just so we can really see that. BC is right here. And that one would have to be the same as AC. Definitely not in this picture. Definitely not in this picture. Okay, you can see because the AC is the longest side in the triangle, so that's definitely not the case. And then the last piece, if they were congruent, then what else would we have to have? We'd have to have that BC is congruent to AC. Okay. Well, let's move to the side. Notice what the student is saying. Zada is saying AC is equal to BC. If AC is equal to BC, the statement is true. Okay, so let's check. First off, do we agree with her statement that this is generally false? And look to what you'd built. Just build a triangle. Make sure it's not isosceles. Yeah. Okay. So hopefully you can convince yourself, yeah, she's on the right track there. Okay. Now let's go back. Now let's see what else she says. She says, okay, so if AC is equal to BC, so I'm going to mark those now. Okay, so AC in the first one is equal to BC in the second one. If that is true, he said, then the statement is true because AC has to be the same as BC. Now BC up in the top one has to be the same as AC. But AC and BC are actually the same. I know I drew it twice, but these have to be the same, which means this has to be an isosceles triangle. So if we say triangle ABC is congruent to triangle BAC, then we already know that BA and AB are the same. The piece we need is that BC has to be the same as AC, and that AC has to be the same as BC. So we only need one statement to make that true, and that would be if AC is congruent to BC. So that's the idea. Draw it, sketch it out. If you have an isosceles triangle, could you make the claim that a triangle is congruent to a different version of itself? And hopefully that follows right through to the end. All right, there we go. So that's it. I hope you have a good rest of your week. If you have other questions, let me know. I can meet with you on Zoom, in person, on campus, before or after class. I can also make a video like this just for you if you prefer. All right, have a great rest of your day. Off you go.